This is CI/CD with Jenkins and Docker. If anyone's here for the wrong one, you can head out. I'm going to be talking about building, testing, and deploying your application with the push of a button or of a push of a commit. I'm Thomas. I work for Cornerstone Systems Northwest. I'm a system administrator. Before I started working on this project, I was mostly a Windows admin with a little bit of Linux administration thrown in. And then the company that I work for, Cornerstone, we develop web applications. And right now we have mostly government contracts, but wanted to develop our own product. And started developing a team awareness, like time management product. And for that, we wanted to branch out into different areas of hosting. And so I started researching this. And there's my email if you want to contact me after the presentation. If you have questions, if we go through, at the end of the slide would be best. Or you can wait till the end and I'll take questions at the end too. So this is the general workflow. We're working with code in GitHub. We push a change to GitHub. Jenkins sees that change and triggers some jobs. Jenkins uses Docker to build those jobs, and then back to Jenkins, back to Docker, and we end up with a running application. So the goal of the workflow is that a developer has new code that he wants to implement. He tests it locally, or she tests it locally, sends it to GitHub, then it's tested again in our environment, and minutes later a working version will appear if everything goes right. So what's GitHub? GitHub is source control management. It's a web-based Git repository. So you store your code for your application in GitHub. Everyone on a project can see all the changes that are being made to it, can make changes to it. It is a method of revision control. So when someone makes a change to the code, everyone can see that. People can comment on that and everything. GitHub is great for manager and developer transparency and operations transparency, because you can see what everyone's working on. Manager can see what you're pushing and say, yeah, this is a great track, keep going on that, or hey, wait, no, back off on that, we don't want that. It also provides a lot of integrations. So my company uses Slack and FlowDoc and email, and GitHub can notify you by all those methods, and it's easy to set up to get notifications so that you know what's going on with your application. So what is Jenkins? Jenkins is an open source integration tool for building and testing projects. It's cross-platform, so you can run on Windows, you can run on Linux, you can run on OS X, depending on what environment you need. You can have, so what we have is a Jenkins master, and we have multiple Jenkins slaves under the master. We have some that are Linux and some that are Windows. So if you have a job that needs a Linux environment, you can put a Linux slave. If you need a Windows environment, put a Windows slave. And a lot of different versions of Linux. It also is integrated with GitHub. It integrates with Docker really well, and it integrates with Slack, FlowDoc, email, all of that. So anything that happens in our Jenkins server, we learn about it through email, which is a more verbose. You can get a full email of the report, or Slack for short notifications, and FlowDoc for short notifications. And a big part of what we use Jenkins for is the test reporting and test reading. So Jenkins will read, the list of your tests. Once you run the test through Jenkins, it pipes a text file to the slave. Slave reads that, reports that. If it finds errors, it'll send you a message that says, hey, your test isn't working. If it finds that there are no errors, everything is good, it'll send you a message saying everything's good and continue on with the next job. So what is Docker? Docker is a container platform. So it's operating system level virtualization. If you want to compare it to VMs, a virtual machine will emulate, the operating system and the hardware, and you have basically a full computer that is virtual running on top of another computer. Containers virtualize just the software portion, so they don't care about the hardware. So this makes them really lightweight. The VMs that I have are, for Linux, they can be between like 2 and 16 gigs, and some even bigger. The Windows VMs I have are like 35 is the smallest one. Bigger than that. The containers are really small. So the smallest container I have right now is 200 megs. They go up to about 800 megs. And hopefully we'll be getting that scaled down a little bit, but I haven't been working on that part yet. So because they're really lightweight, they're also really portable. The plan is eventually to not be hosting on our own hardware, to move to the cloud, or move to someone else's hardware, so that we don't have to worry about that part. With the containers, that's super easy. I can take my existing repository or registry and just pull containers from that, or pull images from that and start containers on the cloud. If I want to, something happens at our hosting and we need to switch to the disaster recovery site, super easy to just be on exactly the same version. It takes a minute maybe to pull the new image and deploy that. So yeah, dependencies. Docker really helps with this, and dependencies and development kind of go hand in hand. A really good story for Docker is if you're onboarding a new developer, normally they have to get their laptop. They need to, for us, they would need to install Node. They need to install the correct version of that, the right version of NPM, make sure everything's in the right path, make sure all their other dependencies are all in order. With Docker, they just install Docker, and they can either build the container from the source code or build the image from the source code and run it right away, or they can pull it, if they're on our network, pull it straight from the registry and use the exact same container, the same image that we're using in production. They can run on their local laptop. Yeah, the other thing, we have a few projects that we're working on. Some of them are running on Node version 12, some Node version 5, some, and with Docker, doesn't matter what version of Node you don't have to have Node installed locally. You don't have to you just have Docker, and you can run whatever version of anything you want. And yeah, the dependencies, so like NPM dependencies, when you run a NPM install, that is all in the image. You don't have to have any of that on your local laptop. So if you need a new dependency for the application, I don't have to do that on all the hosts across the environment. I just do that in Docker, in the source code. So continuous integration, or CI, continuous integration. It's a method of development where each day the developers integrate what they've been working on into the master code repository. So this can be once a day, twice a day, 10 times a day. You are making changes, you're pulling from the application that exists, making changes, and pushing those back. So it relies on a code repository, for which we use GitHub, and it relies on automated builds. So every time a developer pulls his code and then pushes it back up to the repository, we rebuild that code as an application. And with that application, we then run tests against it. So the local developers can run their tests on their laptop. And with Docker, it's very close to what would be the production environment. But there's still, they're running it on a Mac or mostly on a Mac. And they're not using like the certificates for the front end. So there are some small changes. With the continuous integration, all of the tests are running against what would essentially be what is in production. So automated builds, automated testing, and this leads to transparency, which is a big theme of what I'm talking about today. So when someone pulls a code, pushes it to GitHub, it builds. Maybe something they changed breaks one of the tests. That gets posted to Slack and GitHub actually. So when you're having that conversation about the code change on GitHub, you'll see a little red X next to this commit. Click on that X and go to Jenkins, and it'll tell you exactly what test failed, and why the test failed, and how the test failed. And the developer that made that change can go in and fix it, or maybe it's something that is wrong with the hosting, or something that I did that I can go in and fix, or say, hey, maybe you need to change this. It looks like you're pointing at the wrong blah, blah, blah. So continuous integration, leads to transparency. It also removes issues with when you make changes to the master code repository and you're working on that for like days, weeks at a time, you're getting further and further away from what is actually running in production. With continuous integration, the idea is to always be really close to what is running in production. And so when you finally want to merge, your new changes in, you won't have like dependency issues, and you won't have versioning issues, and not as many merge conflicts. So helps with that, apparently, or supposedly. And then the CD part. CD stands for two things. It stands for continuous delivery, and it stands for continuous deployment. We somewhat use both of these, and it's kind of debated a lot whether people are actually doing continuous deployment or if you are doing continuous delivery. And there's a lot of information you can find on that. It's kind of interesting. So both of these rely on continuous integration. You can't have continuous delivery without continuous integration. You can't have continuous deployment without continuous integration. They also rely on a short development cycle. It wouldn't really be continuous delivery if you're checking out changes and every change you're making takes 3 weeks. It's not a short cycle, and it's not continuous. With continuous delivery, every change gets built, it gets tested, and then it gets sent to quality assurance. So there's someone checking, making sure your code is right, making sure what you're doing is what they want to be doing, and then it gets deployed on a change control. So that change control might be every 6 weeks we push the changes to production. Change control might be at the end of every day we push changes to production. Change control could even be as soon as it gets QA, I'll push it to production. But you're manually saying, yes, let's push that piece of code. So that's the key thing of continuous delivery. Continuous deployment differs in that continuous deployment relies on continuous delivery. You still want to have the quality assurance. You still want to have someone saying, yep, these changes are ready to be merged and ready to be deployed. But with continuous deployment, you're doing that automatically. So on our staging branch, every time a new commit gets made, a change gets made to the code, it's built, it's tested, and then it's automatically deployed to our staging environment. On the master branch, on the more production, and we're not actually production yet, we're pre-release, but on the production, the sort of change control we have is, okay, we'll push this change to master. When this change is pushed to master, then it's deployed, but it has to go through certain checks and revisions, and people have to check off on it before it actually goes to master. So that's the CD part, both of them. So project separation, I've touched on it a little bit, but I'll go a little more in depth here. So for the project separation, we have our Jenkins master, which is kind of the automation overlord. It takes care of everything. So under the Jenkins master, we have two of these following chunks, the Jenkins master chunks for each, or actually two of the top and bottom chunks for each environment. So I mentioned we have the staging and we have the production. So on each of those, we have a build job, which is a Linux slave. And when change gets pushed to the Jenkins master, it starts a build job that builds the application. It runs some scripts and then creates some Docker images. And those Docker images get pushed to the Docker registry. And then once they build successfully, it deploys to a CI environment. And so the CI environment is just one host that mimics pretty much exactly what we have in production, but scaled down. Once that's successful, Jenkins kicks off a testing job. The testing job runs on a Windows slave. The application we're creating is, right now it's a web app, and we're supporting Chrome for the initial release. And so the testing job on the Windows slave opens up a Chrome browser, runs tests against that browser using the CI Linux or Docker host, and runs tests, and then reports on a test file and sends that to Jenkins. And Jenkins reads through that test file, makes sure there's no errors, make sure all the tests pass, and then if all the tests pass, it goes to the deployment job. The deployment job is actually the same Linux slave as the build job. And this whole process won't start again until the whole process is finished. So it goes to the build job and sends off some scripts that deploy the Docker images it built previously as containers on the staging or production hosts. So the Docker registry. For us, this is local storage. We use a private registry. When I first got started with this, there was just the public hub, and we didn't want our application being in the public hub right away. Docker now has its own private hosting that you can pay for, but the private registry for us locally is working great, and I really like it. So all the images that get built in the first step all get pushed to the Docker registry. And then from there, they're all pulled from the same place. So when it deploys on CI, that's pulling from this Docker registry. And when it deploys to the staging environment or the production environment, it's using the exact same image as was used in CI. If I want to test something looks a little weird, and I want to test it on my local machine, I can pull the exact same image that we're running in CI, the same image that we're running in staging or production, and host it myself and run the tests. And then there's the Docker hosts. So for each of our environments, we have right now 4 Docker hosts. And they're Linux hosts running Ubuntu 14.04. So we have 3 hosts that are running the actual application. There's on each of those hosts, there are application containers. We recently split that out so that we have each sort of part of the app is a different service. and then there's a static container on each that just serves like static CSS and HTML files. And then on the fourth host, we have a load balancer and any like extra service. We have one right now that doesn't need to be split up into three different application, or three. It doesn't need to be load balanced, so we have it on that machine. And the load balancer is an Nginx container. The configuration for that is stored in source control. So every time anytime change is made to the application, that deploys a new load balancer. So anytime that a developer adds something to the app that needs a new route or needs a configuration change in the load balancer, I don't have to do anything anymore. It just gets built itself and pushed out with everything else. So a lot of this is making my job a lot easier, which is nice too. I was going to do a demonstration, but to really make the demonstration whole, I would need to open up firewall rules to my computer so that GitHub could actually push a notification to the Jenkins server. Didn't want to mess around with that. So I made a short video, and I'll sort of explain as we go along. So I'm not a developer. I don't know JavaScript or anything like that. So I just made a small like mock service. Here's my GitHub repository. So I'm going to go into the public section, which will be hosting static files for the service. I'm going to edit that file and add a new line there. And then once I'm happy with that work, I'll go down to commit. So I'll give it a commit message that kind of explains what I'm doing so everyone else can see what's happening in that commit, and then commit the image. So all of this, so after that commit, that's the only interaction that this system needs from me. Everything else, like I'm clicking around a lot here, but everything else is just happening automatically. So you can see down on the bottom left, there's a build queued up. So that means Jenkins is already, and this is, I think I edited like a little typo I made because it was a silly typing mistake, but everything else is happening in real time except for my pauses. I just screen captured from the commit to see what happened. So Jenkins already knows that there's a build it needs to make and starts on that build. And you can see it working here, and I'll pause a little to show you kind of what it's doing. At the top you can see so it's starting a push by F14MC, which is my GitHub user. It's pulling down that code, checking out the master branch, and then it sends you probably can't really read that, but it's sending a Docker build command. And so that Docker build command is building a node application. So it pulls the container node, version 12, and then runs a couple commands and then does an npm install on that. So you can see it installed all the dependencies on that image, and then tagged that image as the latest version of the image, as well as the tag that I told it to. And then it pushes both of those tags up to my Docker registry. And then you can see there's a second build command there that's just building the static site. So it's pulling from Nginx, removes the default index configuration, and then adds the files from the public directory. Tags that one as latest, pushes those both up to my Docker registry, and then at the very bottom you can probably not see that it's recreating the container app, and then it'll recreate the container static. This is yeah, probably the longest part in this demonstration, but it still takes a matter of seconds. So down here, this is the host that these are running on, and this is all running in one host just for the demonstration. But these could be, so the Jenkins slave could be running on one. It could be building using a Docker daemon from another host, and then launching the apps on 3 hosts or 4 hosts or however many you want. This is all running on one right now. So you can see the last time I ran Docker PS, there were containers from 28 minutes ago, or the images were created 28 minutes ago, and they've been up for 28 minutes. If I run Docker PS now, it is now using images that were created 12 seconds ago, and they've been up for 12 seconds. So you can see it's using the new image that I just pushed. And then here's what was being hosted before. Refresh the page, the changes there, and then go to my little JavaScript application and changes there too. So it's really, for this demonstration, that video was, I think, like 1 minute and 20 seconds or something, and that's making a change, committing that change, Jenkins finds the change, tells it to build, runs the build, and deploys. In reality, like in our environment right now, it takes about, I think about 20 minutes to go from a developer pushes his changes, or her changes, Jenkins finds it, builds it, tests it, and deploys it. And so from the commit to a developer being able to go and look at that application online and see how it is working, it's about 20 minutes. And hopefully I'll be able to get that time down a little bit, but the npm installs are running every time right now, and that takes a while. So can you guys read that okay? Yes?
Is that 20 minutes because of the size of the app that you guys are building?
Yeah, so the 20 minutes is kind of because of the size of the app. We're still pre-release, like getting kind of close to an initial release, but there's some dependencies that are being built that don't need to be built still. Initially, I was using Docker Cache to build the images, and that was like a year ago, and it wasn't picking up. I wasn't using it correctly, I don't think. And so I just kind of gave up on the Docker, on any caching, and said, every time it builds, install every dependency for every container. We're building 8 images each time, so there's 8 different sections of the application that we're building each time, and that didn't really go. The time didn't really increase too much from when we were building like 4 images. So I think the size of the app and how it's, I think you can improve the efficiency if you worked at it, but I haven't yet.
You build a base image that had mostly dependencies in it.
Exactly, yeah, and part of the issue with that is a lot of our services don't have the same base images, and so then But there would be ways to improve that speed, and maybe next year I'll give a talk about that.
Still 20 minutes in comparison to what we used to do.
Yes, in comparison to building it and me having to push that to each host, and it's pretty good, I think. Oh, so thanks for the question. So these are the DockerFiles that I'm using. These are both in GitHub, stored with the application, and so you can see the one on the left is the Node app. It's building from Node version 12, running some commands, copying the source code into the image, and then it runs an npm install, and then the command that's run on the container to start it is an npm start. And then the one on the right is the static, and that's super simple. It pulls the Nginx latest image and adds my HTML, CSS, whatever I need into the container, and it just starts an Nginx process in the container when it's done. So these are both building from Docker Hub. The node and the Nginx image are images that are maintained by each of those teams. So when Nginx makes a change, their team builds a new image based on the new version and pushes that to the Docker Hub. So every time Nginx updates that image, I get a new image. I could, if I wanted more control over the image, build my own base images from source. I haven't done that yet, but it's something that you can do. You can also add completely customize for Nginx, for example. I can add my own configuration files in there that are kept in source control. I do that in source control. You can link to your SSL keys and certificates if you probably want to keep those on the host machines and not keep those in GitHub. But you can link to those so that you can use HTTPS. So playing with images, creating your own base images is very possible. Yeah.
So considering all these images, and you might want to, you test a certain image, and then that same image that's tested is pushed to possibly even production. How do you handle the the configuration management in that? So you have different config files for, different databases. So, in CI, in quality, in QA, your database is different than what you have in production. So there are going to be different configuration files. So how do you handle that with Docker?
So handling differences in configuration files. Yeah. So there's a few things that I don't know if we've completely come across that yet. Some things that do change for us are, say, host names of a VM that we might want to use in a configuration or something. I use variables that are set either through Jenkins, can kind of tell you based on what you're building what variable to use, or that are defined on the host itself.
But you're making an image and you're storing that image in a repository, so that image is baked, I guess. You've got everything on that.
Yep.
Well, that would mean the configuration settings. So
yes.
Is there an automated way that if I take that image, I've tested it, now I want to roll it to the next environment, say, staging, but I have a different database setting, that's all different. So I'm trying to figure out what's the best way.
Okay, right. So you can link to either a database container that's running on, right, so if you have two different database configurations, I guess, for staging or CI, you could link to that configuration, store that on the host. You could create a container that contains that configuration, store it in your registry still, and link those containers together. Like I said, we haven't really come across an issue with that yet. Part of the continuous integration deployment is trying to keep so that I don't need as much specific to the environment, so that on every environment it's kind of the same. We use our data, right? So our databases are in the cloud. We use Firebase, so we link to that, and we use. We're not really storing any hard data on the hosts. Yes.
I maybe is coming off of what he's talking about, but is your production? Are you using Docker in production? So these containers are very similar to what you have in production, or is production running on VMs or regular hardware?
Nope. The production is running Docker containers.
Okay. So with that in mind, if you're pulling an Nginx, the latest Nginx container, then there's a chance that might be newer than production, correct?
The staging might be newer than production. Yes.
So maybe that's where he was going with this, is that you would have a difference between what you're testing and what is actually production, because your container would be newer in your testing environment.
Right.
Would be different configuration.
Yes.
In theory.
In theory, I guess that could be true. But that's fine. If like we pull a newer version of Nginx, like Nginx, what is it, one like 194 or something is running in production, and then 195 comes out and is running in staging. That's great. Then we make sure it's working in staging and merge that to master, and now master is running 195.
It's just in big organizations that I've been working in. They're just so various and sundry different databases, microservices, and they're different for different environments for obvious reasons. For security, one's PCI compliant, one's not. One's a scaled down version of microservices, another one's production. So they have different URLs, they have different IP addresses.
Right. And
all that's different, right?
Right. So certain parts of our environment are static to the host.
Yeah.
And the way we handle those certain parts, so like the upstream files for our load balancers, I can't really keep that in source control because I have 4 different upstream, and so those are stored on the actual load balancer on the host VM itself. And then in this Docker file, I in the compose file, I share a volume. So here's the Docker compose file. So if I have a directory on my host that I want linked to the container when it's running, I add a line volume, and then the host volume, and then give it the volume that I want it to mount to on the container.
So you can externalize your properties on the host VM that are externalized for specific properties there, and you could link to.
Yes. Yeah. We can talk after a little bit too if you want. I'm not super involved in that yet, but I've read about it a little bit. Yeah. So here's the compose file. So this is what actually tells the host which containers to run. So for my demo, I have the app container and I have the static container. You can see they're both pulling from my private Docker registry. They're both pulling latest image. I'm telling it which ports to use. So the 8081 on the left is telling it on the host I'm going to use port 8081, and I'm going to link that to port 8081 on the container, and then giving it a name. Docker Compose is a tool made by Docker that helps orchestrate. I'm not sure what the right word is, but helps deploy VMs. So the standard way to do it is with a Docker run command, which would just be, in this case, Docker run. You give it -p for ports, 8081, 8081, and then a container name, tell it to run as a daemon, and then give it the image. Docker Compose is a great way. Like, my compose files for the CI environment are huge, and doing a Docker run command each time on that would be some insanely long command that I don't want to have to type in anywhere. And using Docker Compose, you can see this is also on the GitHub repository. So this file can be copied to each host that needs it. And again, in here, for our use case, we have the Docker Compose file in GitHub, but the repository is a little different. We have a staging and a production repository. So I have the image be a variable, just image equals like $registry /app latest. And then registry is defined on each host as whatever it needs to be defined as on each host. So that's the Docker Compose. The GitHub Webhook. So this is what tells Jenkins to start building the project. Jenkins has you give it the URL with in this case it's GitHub Webhook. You can customize that if you want. You need to open up some firewall rules to your Jenkins master. And then every time there's a push event, it'll send a post to that URL, and Jenkins will find that post and start the project. You can also use a Jenkins integration. I'm not quite sure which one is the is better if one is better, and you don't need them both, but they're both there to show you the possibilities. The other great thing about GitHub services, you can add, I think Slack has a service, Flowdoc has a service, and Travis CI, Circle CI. GitHub has tons of services you can choose from that'll like post results to your team awareness apps or take care of other jobs that need taken care of. Here's the build info. This is outdated. The Docker plugin by default populates the build name with with the name of each container it builds. And I mentioned we have like 8 or so containers building right now. So you can imagine 16 names that it's populating that build name with. So I finally sat down and figured out how to turn that off, and it's just a little checkbox that you don't decorate the build name. But you can have that if you want. It'll tell you which changes are in the commit, so hence the nice descriptive commit message. It'll tell you who made the commit, what branch it's on, and what the build revision is. So a couple times we've had to go back. There's been problems with something that we pushed, and we say, okay, we got to roll back to the last good build. So I'll just look at the last good build, look at the commit number, make sure that those changes are the right ones. So like, oh, anything before this was pushed to master, and then I can see which build number it was and deploy that container. We only had to do that a couple times, and there's probably an easier way to do it. So here's the actual Jenkins settings. You can see it's triggered on a after a push is changed to, or push is made to GitHub, and then the CloudBees Docker plugin gives you this really nice area to define the image that you're going to build. You can enter in the Docker Hub for the registry. I have my lab private registry entered. Give it a tag. So for ours, it's every build is tagged with version _ build number, which is the number of builds Jenkins has done, and then it automatically tags it as the latest build also. So why do all of this? Well, first we went from a commit in source code to an app running minutes later. For our case in production, 20 minutes, but for smaller applications, it can be like 2 minutes, 3 minutes. Continuous integration and continuous deployment leads a lot to transparency. You can see all the changes that are happening as they're being made. You can see how those changes are affecting the actual code or the application, at least to stability. The more you're maybe I didn't actually touch on this later, but the idea is the more you're pushing to production and the more often you're changing your application, these changes are smaller, so they're not building up as much. So when you do a deployment to production, there's not as much risk involved. So for myself, I am often tasked with make this change. This change is production facing, so it has to be done after hours. Well, what does after hours mean? Is that 5 o'clock I can make that change and then clock off, or do I need to make that change on a weekend? With this new product that we're doing, these changes are made to production as soon as they're ready. Like, we have changes happening all the time. So it creates faster releases, and the faster releases, every 2 weeks or so we have a all hands meeting. We're a really small company, so that's 14 people. And sometimes people have gripes with a recent change that was made. They say, oh, your recent change took away this feature. And they're like, we can't live without this feature. With our process, that change can be remade or recreated or added back in before the end of the business day. We've had it sometimes, like the meeting is at 10 o'clock. By noon, that change is already pushed to production. You hit F5 and it's done. After this slide, it creates an agile application. So if I want to move to the cloud, I can do that super easily, relatively easily. If I want to move to DR, I can do that relatively easily. If I want to scale up, I can do that very easily now, and hopefully we'll need to scale up at some point. And it's really fun to learn about Docker. It's a pretty interesting tool. It's fun to use. And yeah, here's some resources. And let's do questions. You had a question?
Yeah, one of the nice things with VMware is that if you have a cluster, Docker is basically a virtual machine. So if you have a cluster, you obviously have multiple nodes you have to deploy to. So what tool do you use with Docker to deploy that in a rollout to a cluster?
Right, so our environment is really simple right now. We're just 2 IT guys, so I'm only working like not even half time on this, but there is Docker Machine will provision your nodes to use Docker, and Docker Swarm, I think, is what you will use to like scale up or scale down your Docker cluster. And there's actually like the new stuff coming out is really cool, like Docker Data Center. You can just tell it like use these nodes, add these nodes. Okay, I want to deploy to 5 nodes. It doesn't care which nodes you're deploying to. It just deploys to 5 nodes. Or yeah, there's some really cool tools for provisioning.
That's open source?
I believe so, but I think they have like support contracts or yeah,
of course.
It's pay a little bit for the support and good features, or I don't know. Yep.
You mentioned that you're rebuilding your load balancer every time and redeploying that. Does that mean that there will be downtime every time that this task runs?
Yes. Yeah. If someone hits refresh, like right when that Docker recreate command happens, they could potentially get like a bad gateway or 404 or something. But that when the load balancer restarts, it takes like a matter of seconds, and so the downtime is like not really noticeable, and that's something that I want to work more on for sure, is getting better load balancing so there's less downtime. Any other questions?
What did you consider? Well, you're not even using this in a clustered environment or anything, or are you? Like you're talking about orchestrating containers, orchestrating them on nodes. Or like.
So we're using a pretty static environment right now. That is like we have our nodes set up. We know which ones are going to run each container every time.
Okay.
There are definitely methods to have more of like a cloud computing environment where like, the application knows if it needs more containers deployed or knows if it needs an extra node, and you can script. I guess it doesn't do it for you, but you can tell it what to do when it needs more. Does that address your question?
I don't know. I mean, like you were talking about the ways to manage containers and clusters, and like I'm using Kubernetes.
Oh yeah, okay.
Which is kind of similar, and actually, like your Docker compose file kind of looks like the some of the definitions for replication controllers in Kubernetes. So
okay.
So like I don't know. I guess I was kind of wondering if you had looked into using Kubernetes, if you had compared the Docker tools and the Kubernetes tools, if you knew anything about that.
Yeah, so I guess the question is like about third-party Docker tools. Yeah, I've looked into Kubernetes a little bit. I've looked into like Rancher OS, I think is another one. But like I said before, we're a like 2-man IT shop, and so I just haven't had the time right now to actually like get in depth and deploy Kubernetes, and that's definitely something that I would want to check out. It seems like something like that would help. A lot of this is like scripted, So I run like SSH scripts to deploy containers and stuff like that. There's a lot of third-party Docker tools, and I think Docker Data Center and like Docker Cloud is their like answer to the people that are using Kubernetes for that.
Yeah, they're like almost competing products.
Yes.
Like,
yeah.
Like so.
Yeah. Yeah. I'd be interested in checking it out, but I haven't done it yet. Any other questions?
Are you running your Jenkins? Are you running your Jenkins image
With
as
Docker?
a container, or is that? Are you running
No, I'm not. You can do that. You can run all of this with containers. Actually, for the demonstration, that Jenkins was running as a container. I haven't really felt the need to containerize my whole like infrastructure yet, though, and so no, it's installed on Ubuntu 14.04 as a slave. Jenkins slave. Yeah. Anything else? I guess we can end a little early and go to lunch.
So you don't have to handle a lot of complex configuration.
Not really. We kind of designed the application that this is all being used for to not need to do that. So like I said, like our databases we use Firebase, which is